Hey there, Year 901 mathematicians, Mr. Herman here. And apologies that I can't be there for this morning's lesson. For those who were in the lesson during our test on Tuesday, you saw Mr. Ham come up to me and talk to me outside. He was actually asking me if I can go to the Year 7 camp because the teacher that was meant to go fell ill and they needed a replacement really quickly. So because I live around the corner from the camp, I volunteered. So in saying that, and this is why I'm making this video. This here is a new topic. This is topic number 2, and this is linear graphs. And the title for this one is graphing straight lines. On the log sheet, if the teacher has given you the log sheet already, you will see that the first topic is called graphing y equals mx plus c. For the learning goals for this one, we're going to see how or we're going to look rather into how linear equations can be put onto a graph. We're going to look into what a y equals mx plus c graph format is, look into gradients and y-intercepts. We're also going to be looking into x-intercepts and how they work as well. Some of this terminology might be quite familiar to you from the previous years, especially if you're used to graphing lines. Let's just assume that we'll assume that there's a fresh slate and you don't know any prior knowledge. Success criteria for this is to be able to sketch a y equals mx plus c type graph, to determine a linear equation's gradient and y-intercept, and to also work out an x-intercept. And this is going to help us sketch specific lines or graphs. So if you haven't done so already, as always, when we start with a new topic, we're going to write topic up the top. So open your books. Topic, for this case, is linear graphs. Okay, so the topic before was linear equations. Now we're going to look into linear graphs. So there is a link between the two. And the title for this one is sketching or graphing. No, I'm pretty sure it is sketching. Nope, it's graphing. It is graphing, like consistency. We are technically sketching as well, but graphing y equals mx plus c. Now, this y equals mx plus c seems like a relatively new format. You're used to a y equals and then some number x plus or minus another number, but here we've got this m and we've got this c. So let's delve into this. Let's have a look at what this y equals mx plus c business is. So we're so used to equations where there's a x involved and we're going to solve for x, or there are two equations, simultaneous equations, and we are solving for y and we're solving for x. Right now, this format here, this y equals mx plus c. This is your standard format when we want to sketch a graph. Now there is another format as well. So this one here is the first format and the most common format that you'll see. But you will see another format that looks like ax plus by is equal to c. And this is another format that we could see within the textbook as well. Now, right now, we can't see within these two different equations, we can't see any numbers. Remember, these are different formats. Okay, these are formats of equations. And the things that will be replaced when we want to sketch these graphs are m. So the things that are replaceable, this will be the letter m, the letter a, the letter b, and the letter c. These are replaceable. Made a little bit of a typo. There is an e in replaceable, of course. So m, a, b, and c. These variables will be. Actually, I'm going to call them letters in this case because y and x are variables. These letters will be replaced with numbers to get a standard equation. So, for instance, some examples of different forms of equations, which you should have seen already, could be y equals 3x plus 5. or we can have y equals negative 2x minus 8. And we don't have to just stick to whole numbers. We can also have y equals negative 0.5 plus 3.2x, like that. There are different forms. In fact, m and c, because they're replaceable, you can just replace them with any numbers, and what we can have, or what we get, is a linear graph. And then we can just go ahead and put this graph either into a calculator, or we can graph it into a set of axes. This format here, you will see, especially with question 4, which is on the log sheet, you can see different formats, which is 3x plus 2y is equal to some number. Definitely seen this within linear solving simultaneous equations, but we're not going to spend too much time, especially on this video anyways, we're not going to spend too much time for this, but we will later down the track. So for now, let's go back to this format of y equals mx plus c. Y equals mx plus c. Now there are two really important characteristics when it comes to this equation format here. The first one is this letter m, which will be replaced with a number when we see different linear equations. This right here, this m that's in front of the x, and remember it's m times x, this has a special name called the gradient. Okay, you can also have the word called slope as well, and in some cases you will get rise over run. The most common name is the gradient, and the gradient, this m just determines the steepness or the slope of what the line will look like when you go ahead and sketch this. It could either slope really high from left to right, or slope really low from left to right, or it could be a negative slope if it's a negative number. The second thing here, this c, is considered as your y-intercept. Or in other words, if we were to sketch this graph and we replace m and c with numbers, when we sketch this, whatever this c happens to be, so maybe it's 3, the line will cut at exactly 3 on the y-intercept. So when y is equal to 3 on the y-intercept, that is where, for this specific example anyways, that is where the line will cut. So the first thing I want to delve into is the gradient of a straight line or an equation. With this in mind, I've gone ahead and drawn 3 different set of axes. And what I'm going to do is I'm going to show you the 3 different types of gradients that you can have. The first one, when we sketch a line from left to right, if it is going up from left to right, this gradient is considered positive. This is a positive gradient. So when we have an m value within here, this m value has to be a positive number. It has to be greater than 0. So m has to be greater than 0. It can't equal 0, because then that will be 0 times x, which will make the graph redundant in regards to going from left to right. So our m value has to be greater than 0. The other type of slope, the second one, obviously when it goes down from left to right, this is called a negative slope. And here our m value has to be less than 0. Again, can't equal 0, it has to be less than 0. So when we substitute or replace this m with a value that's less than 0 and we go ahead and sketch it, our line will go down from left to right. So in other words, if m is a negative number. And the last one is when our line has no gradient whatsoever. So when the line has no gradient, our m value is equal to exactly 0. And so as I was talking about the x being redundant, because when we have 0 times x, that ends up being 0, and so we'll just have this y equals plus c, and this c is this replaceable number. And in fact, if c in this case was equal to, let's just make this y-intercept 3, that would mean that our equation is y is equal to 3. There's no x that's been attained because our m is equal to 0. So in this case, there is no gradients. No gradients. And that makes sense. There's no slope. Every single time we go across, we always end up at y being equal to 3. Because the x value has no change of any sort because it's equal to 0. The second thing we're going to look into are intercepts. So intercepts, when we look into sketching our graphs, I'm not too sure what type of graph this is going to be in regards to what the equation is. I can't figure it out once I put it down and get the intercepts. But say for instance, we have a line that goes positive, in positive direction. And we've got these two intercepts that happen. There's one here, and this here is called the x-intercept. I'll just put x-int for short. And this one here is our y-intercept, which I'll put y-int for short. So when we draw a graph, regardless of whether it is positive or negative, I won't delve too much into the no gradient or the zero slope. But when we graph an equation, there will always be an x and or a y-intercept that occurs. And there's these special occasions or special considerations that we have to look into. The x-intercept will happen at this point here when y is equal to 0. So let's have a look at this specific area here. We can see that the graph or the line keeps going, and when it hits this point here, it's hit this x value. We know it's a negative value because it's in the negative quadrant of the axis, but it hits y at exactly 0. Because if we line up the y where y is equal to 0, remember this being our origin 0, 0, it hits exactly where y is equal to 0. So every time we look for an x-intercept, our y value has to equal 0. And this plays an important role in regards to trying to find out what our x-intercept will be when we are given a y equals mx plus c type of graph. And then conversely, when we look at our y-intercept, we know that our y number is going to be positive, but more importantly, our x value, in this case, is going to equal 0 for the y-intercept. Because again, we know a y value is going to be some positive number, but at exactly 0, when x is equal to 0, is where it hits for the y-intercepts. So these two important points, x equals 0 for our y-intercept and y equals 0 for our x-intercept, is going to play an important role when trying to sketch our graphs. Alright, I'm going to do a couple of examples, and just for today's class, you're going to focus on just question 3. Question 4 onwards, I'll teach that in class. For now, let's just try to get our sketching linear graphs abilities at an adequate level before we tackle other types of questions. This question right here is taken straight from the textbook, example 16 from exercise 1F, I believe. And this one here is find the gradient and y-intercept for these linear relations, or this rather, linear relations, and sketch each graph. So right now we have a y equals 2x minus 1. Alright, let's see what we can try to determine from this. Y equals 2x minus 1. First thing it's asking for is the gradient. Now, if we compare this to our y equals mx plus c format, oops, we can see some parallels between the two. We know what our m is, in this case it's 2, and we know what our c is, in this case it's -1. You've got to be careful because the sign is also included in trying to determine what the c is. This is for both m as well. So our gradient, in this case, our gradient is equal to 2. Now what does this gradient equal to 2 actually mean? This is just saying that for every step that I go across once, I take 2 steps up. Yeah, let me say that again. So when the gradient is equal to 2, for every unit I go to the right once, I go however many the gradient is telling me up. And in this case, I'll be going 2 up. So no matter where you put a line, or put a point rather on that line, if I go across 1, I will go up 2. If this gradient was 4, for every 1 I go across, it will be 4 up. The higher the number, the steeper the line. The lower the number, between 0 to 1, the less steep the line will be. Okay, so gradient is equal to 2, and the y-intercept in this case, our y-int, is equal to -1. So let's get some numbers on here. We've got our y and our x, we've got our axis, we've got 0 here, we've got -1, -2, -3, -4. 1, 2, 3, 4, -1, -2, -3, -4, and 1, 2, 3, 4. What you will do is, with the paper, the graph paper, hopefully that the cover teacher has it's been handed out. If not, ask for the graph paper. They should have a set with them. I left them in the plastic pocket that comes with the provided work, and you are going to go ahead and create a set of axes using that graph paper, just from -4 to 4 on both x and y. You can pause this video if you wish, or you get your teacher to pause the video, and then once that's done, you can come back. Okay, hopefully you've got this now. So let's put a point where our y-intercept. So remember, our y-intercept is when x is equal to 0. Or in other words, at this point here, when x is 0 to 0, y is equal to -1. Now remember, in the previous classes, this is our x value and this is our y value. So when x is equal to 0, which is here, y is equal to -1. This right here is our first point. And I know for a fact that from left to right, knowing that my gradient is positive, it's going to go from left to right, it's going to go up. So it's going to go up this way. Now, I'm not actually going to determine the x-intercept. I can use that skill set to try to figure out where the x-intercept is and then draw a straight line from that. But the fact that I know that the gradient is equal to 2 means that I can find the next point from this point here. So for every 1 I go across, which is there, I go 2 up, which is here. So 1, 1 lies within, that point lies within the line for this equation here. And let's just double check that. When x is equal to 1, y is equal to 1. Let's substitute x equals 1 into this equation. 2 times 1 is 2, minus 1 is going to equal 1. So our y has to equal 1, which it does. And then from this point here, for every 1 I go across to the right, and it's always to the right, I go 2 up. The only case where it is different is if the gradient is a negative number. In that case, for every 1 I go to the right, I will go however many units down. Alright, 3 points is enough. We can go ahead and pretty much just play connect the dots. So using those 3 points there, obviously you will use a ruler. My resources are a bit limited considering that I am making this very last minute. That is what the graph will look like. Now, remember, if you were to put this in your ClassPad calculator and you typed in y equals 2x minus 1, that's a graph that you will see, assuming that the scale of the axis is consistent and the same. Now, there are some little things that you need to remember when sketching a graph. The first thing is you're always going to put in whatever your y-intercept is. In this case, is 0, -1. The second thing is you need to put these little arrows here at the end of each point to indicate that the line keeps going forever in both directions. And the only reason why we stopped is because that's the amount of room we have for the set of axes that has been provided. If we actually use a bigger set of axes, we would have to sketch it from end to end. The third thing you need to consider is always writing what the equation is next to the line. In this case, this is a y is equal to 2x minus 1. Now, of course, again, because of my limitations of me doing this on my computer, my one is quite messy. You would make sure that you would use a ruler. You would also make sure that the actual equation that you're entering is in a neat manner. I mean, that's relatively neat, but it's a bit skew. You can write it a bit neater than that. We're going to attempt one more example, and then you guys can start on question 3. All right, last example. And this one, I'm just specifically looking at example 18, again from the textbook, sketching lines with only one intercept. And we're going to look at, namely, C, y equals -12 x. There's a few things going on with this special type of line. So y equals, oops, get rid of that, there we go. Y equals -12 x. Now, there are 3 main characteristics that I can see from this. The first one is that the gradient, in this case, there are 2 things going on with the gradient. The first one, it is a negative gradient. The gradient is negative because it's negative number. So from left to right, it's going to go down from left to right. The second thing from this gradient, it's that it is a fraction. This gradient is a fraction. It's a number that's less than 1. So this plays an important role in regards to its steep or its slopeness. It's going to slope not as fast as a bigger number would, a number that's greater than 1. And the third thing we can point out is that a y-intercept is actually non-existent. There's nothing here. There's no plus something or minus something. Well, technically, C is 0. A y-intercept is 0, meaning when x is equal to 0, y is equal to 0. When there is no number as our C, your intercept is going to happen right in the middle of what's called the origin. Okay, so be very careful with this. It's not going to hit anywhere within the y axis other than the origin. It's the only spot that's going to hit. Okay, so we know our first point is here. Now I've been kind of indicating that the line goes like this. This isn't the case. The line goes down because it's a negative gradient. -1, 1 rather, there we go. 2, 3, 4, -1, -2, -3, -4. Now again, when you guys sketch your graphs, make sure that you choose a scale or set of numbers that is appropriate to the equation that you get. Okay, and you will determine the different points first, and then you can use that to determine what the scaling of your graph should look like. In this case here, for every step that I go across to the right once, I am going down because it's negative, and I'm going down half a step. So for every, let's use this as a starting point. For every line, or point rather, I go to the right, I'm going to go down half a point. So from there, every one to the right, down half a point. One to the right, down half a point. And what you will see is our slope is not as steep. It's not as steep. There we go. Now, I'm only doing so many dots, or so many points. It's going to help me sketch this. Ideally, you could just use 2. Once you've got your 2 points, and you've got a ruler, you can just go ahead and sketch the actual line. That's terrible. I'm very terrible at sketching lines freehand on a computer, but I'm sure you guys forgive me. There we go. Alright, there are my arrows to indicate that it keeps going forever. 0, 0 being our origin, and y equals -half x being our graph. And that concludes this portion of the video. I was hoping to get it under half an hour, which I did. You can go ahead and attempt question 3 from exercise 1F with the help of magical software editing. I want to put the set of questions up right there. Huzzah! There they are. For now, that's my phone going off. This is me signing off. I'm making this on a Tuesday night, so tomorrow I'll be at the camp. And while you watch this, I'll be at the camp. Take care, guys. I'll see you the next day. Bye.